All right, let's dive in. We're talking about a topic that has felt like it's just over the horizon for, what, a decade now? Fully self-driving cars. But something has really fundamentally changed. We're seeing this sudden, almost unbelievable acceleration in the tech, and today, we're going to unpack exactly what happened. I mean, this is the big question, right? For years, true self-driving was always just around the corner. It was this promise that was perpetually a few years away. So what broke the logjam? What finally flipped the switch from this slow, steady crawl to an absolute, full-blown revolution? You know, this timeline really says it all. After the industry set the standard framework back in 2014, we had this long period of just incremental progress. It was slow. Then, right around 2022, the curve just goes vertical. It shoots for the sky. Honestly, we've seen more progress in just the last couple of years than in the entire decade before it. That's the crazy acceleration we're here to figure out. Okay, so to really get our heads around this massive leap, we first need to be super clear on the target. What is everyone chasing? It's level 4 autonomy. And look, this isn't just another fancy driver assist feature. No, this is the critical jump from a car that helps you drive to a car that genuinely drives itself. So what even is level 4? Well, in a nutshell, the official term is high automation. What that really means is the vehicle can handle everything, and I mean everything. Steering, braking, navigating, all of it. But it's within a specific zone, like a mapped-out city or a certain highway. Inside that zone, you're not the driver anymore. You're just a passenger. And here's the key difference, the thing that changes the whole game, the jump from level 3. In a level 3 car, yeah, the car is driving, but you have to be ready to grab the wheel at a moment's notice. With level 4, that responsibility just vanishes as long as you're in the zone. It's the difference between supervising a teenager with a learner's permit and having your own personal chauffeur. That is the freedom everyone's after. Which brings us right to the heart of it, the answer to our big mystery. This whole revolution, it wasn't because of one single discovery. It was the convergence, this perfect storm, of 6 key breakthroughs in AI, all happening at once. And here they are. We've got foundation models, end-to-end architectures, reasoning models, simulation, a massive leap in compute power, and of course, deeply integrated AI safety. Let's break each one down and see how they all snap together like puzzle pieces. First up, foundation models. And this quote just nails the concept perfectly. Think about it. When a teenager gets their license, they aren't starting from scratch. They're bringing a lifetime of common sense to the task. They already know that a ball rolling into the street might be followed by a kid. Foundation models? Well, they give the car that same kind of general internet-scale world knowledge. It can now reason about totally weird, new situations it's never actually seen before. Next, we've got a total redesign of the car's brain. The old way of doing things was really clunky and fragmented. You'd have one computer module for seeing the world, another one for planning a route, and a third for actually controlling the car. And at every handoff between these modules, you'd lose important information. The breakthrough? A single end-to-end network that takes all the sensor data and turns it directly into a driving decision. It sees, thinks, and acts as one unified system. The result is just a much smarter, smoother response. But you know, it's not enough for the car to just make the right move. We need to understand why it made that move. That's where reasoning models come in. They let the AI analyze a really complex situation, weigh all the different outcomes, and then explain its decision-making process, step by step. It's almost like it's thinking out loud. And that is absolutely crucial for the developers trying to make it better, and maybe even more important for us to actually trust the machine. Okay, so here's a huge problem. How do you possibly train an AI for every weird thing that can happen on the road? I mean, you can't just drive a car around for 200 years and hope you see it all. Relying only on physical, real-world testing to cover every single edge case, it's just not possible. The math doesn't work. The solution, and it's a brilliant one, is simulation. Using AI, developers can create these incredibly realistic digital copies of our world, digital twins. And then they can throw unlimited scenarios at the car's AI. They can even just type in a command like create a sudden thunderstorm and put a stalled truck around the next corner. They can test the AI's reaction over and over in a totally safe virtual world. Now, the one thing that makes all of this possible, the raw engine driving these other breakthroughs, is an absolutely insane explosion in compute power. Training these gigantic AI models, running those photorealistic simulations, and processing a fire hose of sensor data inside the car in real time, It all takes a staggering amount of specialized computing horsepower. And finally, the piece that holds it all together, AI safety. And listen, this isn't some feature you just hack on at the end. For Level 4, safety has to be built in from the ground up. It's a system of guardrails that's woven into every single stage, from the initial design to deployment to validation. It's what makes the entire system reliable enough to trust with our lives. So we've got these 6 incredible breakthroughs. But the real magic, the true genius, isn't what they do on their own. It's how they connect and supercharge each other. Together, they create this incredibly powerful innovation feedback loop, this virtuous cycle of getting better, faster, all the time.
So, check this out. Here's how this amazing cycle works. First, the AI models get trained on huge amounts of data back in the data center. Step 2, those brand new models are tested like crazy in those realistic simulations we talked about. And finally, step 3, the refined, battle-tested AI gets deployed into the car's onboard computer. Then, all the new data from the cars on the road feeds right back into step 1, and the whole cycle starts over again, getting smarter, safer, and better with every single loop.
So we've solved the mystery. We know what changed, we know the tech is finally here. But that brings us to the biggest question of all. Why does any of this matter? What's the real-world impact of finally cracking the self-driving code? When you boil everything down, when you get right to the core of it, the ultimate goal is both incredibly simple and incredibly profound: to systematically remove human error from the act of driving. That is the North Star for this entire massive effort. And this chart, wow, this shows you exactly why that goal is so important. The stakes really couldn't be any higher. It's estimated that something like 94% of all car crashes are caused at least in part by human error. 94%. The potential to save lives, to prevent injuries, to save resources by tackling that one single overwhelming cause, it's almost impossible to calculate. So, here we are. The breakthroughs have all lined up. That innovation loop is spinning faster and faster, and Level 4 technology is no longer science fiction, it's arriving now. And that leaves us with one last big thought. The question has changed. It's no longer if our roads will be filled with autonomous cars. The real question is, how fast is this all going to happen? And how is our world going to adapt when it does?